In the last module, we looked at the nature of systems and at the system lifecycle. In this module, and in this presentation in particular, we turn our attention to the principal focus of the course, systems engineering. Now here we introduce what we mean by the term systems engineering, and we provide a framework within which we can consider the major processes, the activities, and the artefacts throughout the remainder of the course. There is a very wide range of system engineering definitions, each of which is subtly different because it tends to reflect the particular focus of its source. It's not of any great use here, therefore, to go through all those definitions. You'll find them in the books and the standards in the course bibliography. Rather, it's more useful to extract from them the common threads so that we can focus on the key tenets of the discipline. Now, if you look at all those definitions, then the common themes are, first, a top-down approach. Now, that's quite different to the traditional bottom-up approach that we use in engineering activities. There is a focus on a formal requirements engineering activity, ensuring that we get the requirements right. There's a focus on the system lifecycle rather than just on acquisition, and there's also a focus on ensuring that the system is optimised and balanced. We focus on integrating a large number of specialisations and disciplines, and we also focus on the management of all aspects of the system lifecycle. So let's look at each of those aspects in a little bit more detail. The top-down approach. Now, as I mentioned earlier, traditional engineering design methods are based on bottom-up approaches, in which the known components that are known and trusted to engineers are designed and built and then combined into assemblies and then into subsystems, and from which then the system is constructed. The system is then tested for its desired properties, and the design might be modified in an iterative manner until the system meets the desired criteria. Now, this approach is valid, and in fact it's extremely valid and well trusted in engineering, and this is very, very useful for relatively straightforward problems that are well defined, such as low-level technical problems, or at least for problems that we've done many times before, and that's what we call engineering. Unfortunately, complicated problems which tend to have a fairly novel face can't be solved with the bottom-up approach. In systems engineering, therefore, we begin by addressing the system as a whole, which facilitates an understanding of the system, its environment, and its interfaces before we go about specifying exactly what's inside the system. We start, therefore, with system-level requirements. Once we understand those, the system is then broken down into subsystems, subsystems broken further into assemblies, and then into components, until a complete understanding of the system is achieved from top to bottom. This top-down approach is very important in managing the development of complicated systems. By viewing the system as a whole initially, and then progressively breaking it into smaller and smaller elements, the integration of those components can be understood more thoroughly, which then assists in identifying and designing the necessary interfaces between those various elements. They're the internal interfaces, and of course then the interfaces between the system and its environment, the external interfaces. Now, perhaps the best example of this top-down approach comes from NCEIA 632, the standard, which provides a product perspective. And this is the top-down process from 632. Note that the system is decomposed into end products and enabling products, all the things that need to be done to produce the end products, and we saw this before. The end product, though, can be considered to comprise a number of subsystems, each of which can be considered to comprise an end product and an enabling product. Then each of those end products can be considered to comprise end products and enabling products, and the process can continue until all the leaves of the tree have been developed, where the leaves of the tree are the work packages that need to be done to allow the system to be built. The work packages get allocated to individual teams or individuals to actually do. Of course, the flip side of top-down design is bottom-up integration. We can see here another representation of top-down design on the left-hand side of the diagram. The system is decomposed from a system into subsystems, subsystems decomposed into assemblies, assemblies decomposed into components. And that's the development. On the right-hand side of the diagram, though, we have the flip side of top-down design, which is the bottom-up integration. Components are built, tested, and then integrated into assemblies. The assemblies are then tested and integrated into subsystems, which are then tested and integrated into the final system. The system is then finally tested for its desired system properties, and so we've completed that cycle of top-down development and bottom-up integration. If you're interested in reading further into the topics we covered in this presentation, you may wish to read the corresponding chapters in the texts associated with the course.